piece. That doesn't make sense. The bishop works in a very similar way. Again, we have these 6 new variables, 4 integers, 2 booleans. And for the bishop, you count the bottom right and bottom left directions as the bottom and left directions of the rook in a way, but just the diagonals, and you just do work from there. So this is the code for that. That's the code for down right, as you can see. This is the code for down left. This is the code for up left, and this is the code for up right. They work in the same way, and we even have this if else if inside of here. And next is the queen. In the queen we just copy pasta. That's it. So we have 12 new variables, 8 integers, 4 booleans. And in the corresponding places we just copy and paste from the rook and the bishop. We don't have to do any kind of editing on the code that we copy. So the code which I have added on is this code, this code, this code. That's for the rook side of things. And then we have, for the bishop side of things, we have this, and this. And then at the end I have the if-elif statements merged together. Now you might be wondering, why have I used else if and not if? Well, one piece can only pin one other piece. It cannot pin 2 pieces. So I can get away by just using else ifs and not ifs. And that does make my code slightly more efficient. And then in the game manager, the changes are very small. After the piece of code, so we are still looking at check situation of board. We're still looking at that method. After we go through all of the pieces, checking for the king and checking its valid moves, we add another for loop, so we go through all of the pieces again. And, well, we just look at which piece they are pinning. So if it's pinning a piece, so if there is a piece on the square which we are looking at, and if it is pinning a piece, then we clear all of its valid moves so that it's not allowed to move. And we do it here in a new loop because we want to make sure that the king, if it's in check, stays in check. So for example, you could this rook could have been pinned, but it's still attacking this pawn. So if there was a king here, the king would still be in check even though this rook was pinned. So I'm talking about a situation such as the queen is here, my white king is here, and this rook is pinned, but the black king is also here. The black king would still be in check even though the white rook would not be able to move. But if we removed white rook's valid moves earlier on, then we wouldn't be counting that position as black in check, but we do want to be counting it as black in check. So that's why I've added this, and I've just rearranged something that did not look nice. There we go. So that's literally the only few lines of code that you need to add into the game manager for, what's this? For the unpinning of all of the pieces. And actually, no, it's not. I just remembered. There's one other thing. I made another method called Unpin Old Pieces. So, because there's nothing to unpin all of the pieces, in the check situation of board, before I do all of the checking, I unpin all of the pieces by using a new method which I have created. It's private because nothing else needs to use it. And what I do is just go through all of the pieces on the board. If they are a rook, a queen, or a bishop, because those are the only ones which can pin, I make sure that they are not pinning anything. And there we go. Actually, do I even need that? I might not even have a need for that, because I think that I make... Oh no, I don't. I have to have that because I'm doing the pinning... I'm I assigned the variable pinning in my piece. So if I really wanted to, I could actually do that over here. At the top of all of these, I could instead change pinning the piece and make it equal to null before I do everything. This should also work, and this would mean that I wouldn't have to be adding the extra method in my game manager, which would make it better. And let me just test it out really quick. And yes, this does also work, which means that we can just completely discard that method, because at the start of all of the checking that we do, and we only do this checking once, we just remove pinning. We just say that this piece is not pinning anything and then do the checking for it anyway. So this is our chess game logic all done. The next video, what we're going to be doing is telling the winner. So we've already got that, we've got the code for it, we just need to make a visual representation of Checkmate. This video might actually be in 2 parts, I've noticed, because it turned out much longer than I was expecting it to. So yeah, if you're finishing this on the second day, then thank you so much for watching. And well, if you like this video, then please give me a like, share and subscribe. If you have any questions, as always, do feel free to ask in the comments down below. Until next time, goodbye.